All right, so just following on from the same skill we were talking about, guys. It's a short extension, if that, and we get to use our calculator. So we can even simplify the process. Boys, we can simplify the process even more. So cumulative binomial probability distribution. So we have given a crate of 50 apples now. Given a crate of 50 apples, the probability of a random apple being rotten is still 0.35. Determine the probability that from this crate of apples, exactly 50 are rotten. So I've typed this into our calculator. You don't have to type the whole formula in anymore. We've got the probability of exactly 20 being rotten. We're going to go stats, distribution, binomial, and you can do it either in RunMat or you can do it in your statistics menu. I think it makes probably more sense to do it in RunMat, okay? So if you're in RunMat, you press option first. Option, stat, distribution, binomial, and you can see there's two options. There's BPD or BCD. BPD, exact outcome. That's exactly what we were doing before. BCD we'll get into in a moment. So BPD says exactly 20 apples being rotten. This is the probability of 20 successes. So if we were to use the same process as before, we would be going C, 50, 20, probability of success to the number of successes, probability of failure to the number of failures. That's how we would do it, okay, if we were going to use the same process. We're not going to do that. We're going to do it a little bit differently. Instead, we can press BPD and we type it in this order. We've got number of successes, number of trials, probability of success. Okay, so in our circumstance, if we're typing in BPD, we've got 20 successes out of 50 trials, and the probability of success is 0.35. Okay, so much faster to type into your calculator, right? BPD 20, comma, 50, comma, 0.35, close the bracket, execute. Where's the comma? Just below the cos button, because that's where it goes. All right, so we evaluate that, we get 0.0875. 0.0875. So that's the probability of 20 out of 50 apples being rotten. Okay, move on to the next part. It says more than 20 apples being rotten. So if we think about how many apples you could have rotten, you could have 0 rotten apples. That means all 50 are ready to go. You can have 1 rotten apple. Okay, all the way up to, we can have 9, I'm going to put a few numbers here, 19, 20, 21, 22. Now, this event here, we calculated the probability of exactly 20 apples being rotten. That's what we did in part A. Have a look at part B. More than 20 apples being rotten. If you have more than 20, that's talking about this event here. You could have 21 rotten apples, you could have 22, you could have 23, you could have 24. And so what the calculator is doing is it's going, okay, it's the event of 21 apples rotten, plus the event of 22 apples rotten, plus the event of 23 apples rotten. It's going to add all of those up for us. We don't need to do it manually. And so we go, same process, B, C, D. C for cumulative. It accumulates. It's the cumulative sum of these events. And so we're going to say, what's the probability of X being larger than 20? Larger than 20. Now, if it's larger than 20, all right, this is where our greater than and our greater than and equal sign are important. This means the same as it being larger than or equal to 21. Okay, because the next possible value after 20 is 21. All right. Remember I said an apple's either rotten or it's not. Okay, there's no half apples being rotten. It's either rotten or it's not. So when we're considering whole integer values, if we've got more than 20, okay, the number of apples that are rotten is more than 20, it means the same thing as 21 or more apples being rotten. Okay, so then we're putting it into our calculator like this, okay, following these same prompts, B, C, D. We have a lower boundary, okay? What's the lowest amount of apples that can be rotten? And then an upper boundary. The lowest amount of apples that can be rotten is 21, okay? So our first number, 21, comma, our upper boundary, okay? We're saying more than 21. So 21 all the way up to how many possible apples are there? Maybe 50. All 50 of them being rotten, okay? Number of trials, 50. I've typed it in here. Lower boundary, upper boundary, number of trials, and probability of success. That's the syntax we're putting into our calculator. So B, C, D. Ooh, option, stack, distribution, binomial, B, C, D. 21, 9 plus 10. $21, 50, 50.35. Okay, we've got 0.186. 0.186. Very good. That's part B. All right, part C. Part C says, how about less than 20 apples being rotten? If we're talking about less than 20, okay, less than 20, under 20, we're talking about all the way down to 0 apples, isn't it? It's talking about this possible event here. We've got 0 apples rotten, plus the probability of 1 apple being rotten, plus the probability of 2 apples being rotten, all the way up to 19, because it has to be less than 20. So for part C, we're doing B, C, D. Our lower boundary that we're including, we're always including the boundary, 0. We can have 0 apples rotten, all the way up to 19. Okay, remember it says less than 20 apples being rotten. Out of 50 trials, there are 50 apples, and the probability of an apple being rotten, 0.35. So that's going to be our syntax for part C. 0, 19, 50, 0.35. Yeah. Yeah, of course. Yeah. We've got 0.7264. Okay, now we're going to answer part E before we answer part D. Part E says, what is the significance of the sum of your results from part A, part B, and part C? So if we add up these probabilities together, this one plus this one plus this one. They're our answers to part A, part B, and part C. Anyone want to guess what we're going to get? 1. Why? The sum of all the probabilities will be 1 because all probabilities add to 1. It's the probability of every event. I've got between 0 and 19 apples being rotten, plus 20 apples being rotten, plus 21 to 50. It's all possible events. There's no other events outside of that. So all of these probabilities added together has to be 1. The justification, the sum of all probable events is 1. Okay. Now let's do part D. Between 20 and 30 apples are rotten. So what that means is, one way we can write that is it's the probability of 20 apples to 30 apples. Now notice it's inclusive. Okay, I'm including 20 and I'm including the 30. Alright, if it says between 20 and 30, that's a little bit ambiguous, isn't it? Between 20 and 30 apples are rotten. Let's include them. The language will always be precise. So we've got B, C, D, 20 apples to 30 apples out of 50 apples, 0.35. Very good. 0.2734. 7.2734, which is 0.273. Excellent. Okay, so let's do a few questions. We don't need to do all of them, so if you just turn the page, that's where you'll find the questions on BPD and BCD. And from now on, like I've taught you the binomial distribution formula, all right, but you can use either of these when you have an exact question. So I'll make a list of the ones I would like you to do. Okay, we don't need to do all. So you can if you want to. Cumulative distribution questions. Let's do question 2. Question 3B. Question 6B. Question 7 and question 8, that'll be plenty.